I am there now. Let me get this out of the way. We were talking about alternative energy, about nuclear energy. So we talked about nuclear radioactivity, about three radiations: alpha, beta, gamma radiation that is emitted by radioactive sources. So we're going to look into effect of radioactivity on annual dosage, how we measure them, and how we can prevent exposure, etc. So annual dosage of radiation damage happen to humans when radiation is exposed to, when they are exposed to radiation. Radiation exposure causes ionization in the tissues that can lead to mutations, radiation damage, and other disease conditions. One of the units that we measure radiation is called RAD, radiation absorbed dose, RAD. Is equivalent to 0.01 joules of radiation energy per kilogram of tissue. Based on this definition of radiation dose, we have created another two radiation measuring units, RAM. Roentgen equivalent of man is equal to a Q, which is a factor, times the RADs as defined previously. So Q is a relative factor depending on the tissue types. That can vary. Some tissues are vulnerable for radiation damage, they have higher Q. So for different tissues and animals, we have Q ratio, Q factor. So we also measure radiation doses in SV, severe. Is simply 100 times RAM. Normally, RAM is the one we use for radiation dosage. So if you look at radiation dosage in severe and RAM, 0 to 25 exposure based on this RAD definition and RAM definition, there's no observable effect on the tissues or living organisms. 25 to 50, I stick to RAM now. Severe is RAM divided by 100. So severe divided by 100 is RAM. Severe is 100 multiplied by RAM. So RAM-wise, 25 to 50, white blood cells count decrease slightly as you get exposed to higher dosages. 50 to 100 RAM, significant drops on white cells count, significant. So 100 to 200, nausea, vomiting, loss of hair. 200 to 500, hemorrhage, ulcers, possible death. So as the REM levels are only 0 to 25 is safe. Also, it depends on how long you've been exposed to. People working with radiation, X-rays, and X-ray is a ionizing energy source that can cause radiation damage. They have badges that indicate how long they have been exposed to radiation, and their annual dose is exceeded, then they are stopped from working in the lab for time. to catch up with radiation dose requirement. So your annual ionizing radiation dose is guided by EPA in their website given here, which demonstrate various sources of radiation that we are exposed to on a daily basis. It outlines radiation sources, different neighborhoods. If you go there, you can find that out. Using NRC, Nuclear Radiation Commission's website, you can calculate radiation levels that you will be exposed depending on where you live, annual dosage. How does your annual dosage compare to annual dosage of others in the class or average annual in exposure in different places in the United States? So when you calculate annual dosage for you using NRC site, there are geographical factors, elevation, then nuclear energy sources, and presence of radon, other radioactive nuclei are taken into consideration depending on your location. So you can adjust your lifestyle to reduce exposure to ionization radiation. These radiation, X-rays, alpha, beta, gamma, can cause changes into your tissues, changes in the component of your tissues. They can affect genetic code and create mutation and can create cancer, cause cancer. So I calculated my radiation dose calculation based on where I live in Preston, Louisiana. The radon in the air is 200 milligram, very small amount. 44 area of residence, that's where I live. Diagnostic X-rays, they consider how many dental X-rays or chest X-rays you are taken into average per year. Some food also water has some radioactive, small amount of radioactive material, that's 40 milligram. Elevation from the sea level. Where I live is 29. High elevations, closer to the sun, you have more radiation exposure. Cosmic radiation depend on the elevation. Annual jet travel. You fly in the high above the stratosphere, troposphere, or close to stratosphere. So that exposes you to higher radiation dose. Video displays also emit certain radiation. Television viewing, porcelain crowns and false teeth. Some of them have radioactive material, very little. Smoke detectors also have radioactive source, which create ionization radiation and beep when smoke is passing through them, breaking the ionization radiation that create the circuit. Luminous wristwatches also have some radioactive material. So my annual dose, total dose was 394, close to 394 milligrams. So if I am worried about things that I can do certain things, not going out to areas where radiation material is more there's high level of radioactive material. All right, so you can calculate your own annual dosage from the freest light. So now we are going to change the topic to understand the effect of radioactive material on us. Effect of radioactive material is dependent on how long they're going to be around before they decay. That's the how long they last is measured by half-life. Half-life is the time required to certain radioactivity level to fall to 1/2 of its initial value. It could be number of grams of radioactive material or activity of radioactive material. So if you look at this time years, originally sample containing percentage of sample. If you start with 100 grams, half-life is time that is taken to it become 50. You see 100 to 50, the half-life. For this particular species, the half-life is 24 years. Two half-life is twice that, then it becomes 25%. Like that, in a graph, you can see how it goes down. The shorter the half-life, the material will be gone faster. So their effect is on the living organisms are smaller. Therefore, half-life is an important parameter of a radioactive material that can tell how much damage it would do if left around. Looking at half-life again, number of half-life remaining is 0 is 100%, remaining is 50 after one half-life, decays is 50. It's the remaining decrease and decayed increase within the 100% range. So you can see that, for example, after 6 half-life, almost 98% is gone. So 6 half-life, if it is shorter half-life, 1 hour half-life, after 6 hours, 98% is gone. Shorter half-life is less damaging. If you have longer half-lives, they're going to be hanging around here a long time. Even if you have years of half-life. So after 6 half-life means a lot of years. So radioactive material could do more damage. The half-lives of some radioactive isotopes, radioisotopes, are given in this table. Uranium-238, 4.5, 10 to the 6 years. That's going to be around long time. Since the formation of Earth from the breaking up of planetary material or condensing of planetary material, that's billion years of age. So still some 238 is left on Earth. Potassium-40 is 10 to the 6, I think it is 6, 10 to the 9, 1.3. Uranium-235 has a little smaller half-life, but still uranium-35 has long half-life. Plutonium has 24,000 years of half-life. Carbon-14 has 5,000 years. Cesium is 30 years. Strontium is 29 years. Thorium is 24. As you see that material has shorter half-life and less damage they can do. For example, strontium is released from nuclear reactors malfunctioning like Chernobyl. We're going to talk about that. That material is going to be there for a long time because 29.1 years. 6 to become 6 half-life, that means 6 times 29. That's going to be around 200 years. So we have to wait till they decay to remove strontium-90 from the biological accumulation in milk, in cow's milk, so milk will be safe. So the problem is how we store radioactive waste. The radioactive wastes are created by nuclear reactors. As we do fission reaction, various radioisotopes are produced. So they're going to have long half-life. So we have to put them in a depository. So most nuclear wastes are stored on-site. Next to the nuclear power plant, there are underground concrete water tanks that we store the nuclear rods and things like that temporarily before it cool off. After that, we make them into concrete slabs or put them in blocks of concrete and transport them into different locations. One of the places they picked up was Yucca Valley mountain in Nevada. So, however, this is a controversial issue. Nevadians didn't want to have nuclear waste site deposited in their state. So 2019, even in 2019, there's little progress about that. So why we pick Nevada? Because there's less earthquakes there, and then they could be there forever almost, but you cannot predict what's going to happen. That's the uncertainty about earthquakes and ground shifts. There is considerable risk operating nuclear power plants. In April 1986, I remember in 1990s, 91 or something, there's a 3 Mile Island nuclear reactor release of radioactive in New York. But that was a minor compared to Chernobyl nuclear accident. In 1986, in Kyiv, in Ukraine, under Russian rule at that time, nuclear power reactor blew up during routine operation. Nearly 9 tons of radioactive material, 10 times as much as the Hiroshima bomb, were thrown into sky. Winds over the following days carried towards northwest fallout into Belarus and Russia, Poland and Baltic region. Control rods were made out of graphite. So control rods containing nuclear fuel was made out of graphite. Once the primary coolant system failed, that nuclear rods are heated up, and they had graphite as a covering material. That graphite reacted with water from the leaking cooling system. While performing safety tests in reactor, technician allowed large surge of power in the reactor. That surge caused nuclear explosion, where burst out pipes containing water, reactor with graphite, hot graphite of cooling rods produce hydrogen. Hydrogen is an explosive gas at high temperature. So hydrogen reactor is water causing the explosion. Hydrogen with oxygen produce water. The 400-ton concrete covering over the reactor was blown away. Fires broke out in many places over the site. 50 different radioactive isotopes were released with half-life spanning 2 years to 24,000 years. These isotopes were shot 1.5 miles into the sky. One of the hazardous isotopes released was iodine-131. Iodine has a tendency to accumulate in thyroid glands. Thyroid glands need iodine. So accumulation of radioactive 131 iodine in thyroid gland causes thyroid cancer because of the ionization of tissues from the radiations emitted by radioactive 131. So 131 decays by beta emission to xenon, and gamma radiation is produced. So both these radiation are ionized radiation, beta and gamma rays. As consequence of Chernobyl accident, over 1,000 injuries, 31 deaths of firefighters, and who reported to scene of the accident. 150,000 in the neighboring area were evacuated. Radioactive cloud released over a large part of Europe. Estimated future cancers from accident range anywhere from 7,500 to 1 million. So Chernobyl is still isolated space, then people don't go there, cannot go there, a lot of radiation. It will be years before we can open that up. Maybe 300 years or 400 years. Radioactive particles in the environment and food chain make the area inhabitable for people. So large amount of uncertainty and fear is created in the population. As a consequence of Chernobyl accident, hold on a second, in government, because they had a kind of a socialistic government, there's no private sector or input from democratic process. Soviet Union tried to cover it up. Sweden and Poland were the first nation to bring bring accident into the attention. Other nations attempted to downplay because of health effect of the own nations. They didn't have any remedy what to do about it. They tried to downplay. Public opposition to building additional nuclear power plants increased significantly worldwide. So that is the status of the nuclear power. because of this accident. This accident caused a lot of panic among normal people about the use of nuclear power. Another disaster came after Chernobyl was due to tsunami that took place in Japan, Fukushima, one of the islands or in Japan, one of the places close to Tokyo. So this is caused by tsunami. Floodwater knocked out the tsunami, floodwater created by tsunami knocked out the generators needed for cooling water. This caused overheating of fuel rods, which then started a chemical reaction that generated. It's similar to Chernobyl. Here in Chernobyl, the hydrogen was vented, releasing 131 again to the countryside. So despite of whatever they did at that time, there were 4 reactors affected out of 6, which released large amount of radioactive material. Same story like in Chernobyl. Still, the city where they had the reactors are inhabitable. They had to wait till this cool off. It might take about a couple of 100 years to get things back to normal. So future of nuclear power is uncertain. It increased until about 1987, since the disaster, 3 Mile Island and Chernobyl and Fukushima. There were not many nuclear reactors were built because of the fears. But there's a tendency to increase the efficiency of that orange line or yellow line. The efficiency will increase, but there were very few building of new nuclear power plants. However, electricity generated from existing nuclear power plant increased. The power increase over time stems from both improvement in reactor efficiencies and upgrade to the reactor components. They are repairing and maintaining them more efficiently right now. So it's like you had a bad accident, then you don't go to any place, stay home. It's just like that. We don't do anything about nuclear power, but it's going to pick up eventually with the global warming because we had to cut down carbon dioxide emissions. Nuclear power in US. These blue states has nuclear power plants. 29 states have nuclear power plants. We can look into how the energy is produced in different states. We go over that for different states, Louisiana and Kentucky and California. So as of 2009, New Hampshire was the state with the highest percent of nuclear power. 72% come from nuclear power. Since the search the internet to find more states that use more nuclear power. From the map selected, state with no electrical power plants. How is the state electricity generated? How about New Mexico, Colorado, that state in the middle from New Mexico going up Colorado, Utah, and other states in the middle, Midwestern. So they must be burning coal. That is for sure. The energy has to come from somewhere. So coal burning is the other energy source they have. Now, some countries are trying to expand or use more nuclear power. One of the countries is Far East Asia, including China. Other countries are Middle East and Southeast Asia. Central and Western Europe also trying to increase nuclear power. So eventually my feeling is we're going to increase nuclear power because there's no other way we can produce more electricity without burning coal. The safety is a concern, therefore the procedures has to be improved. Significant expansion of nuclear power facilities are underway in most developed countries, especially in Asia and Europe. How we can prevent another nuclear disaster? According to NRC, Nuclear Regulation Committee, following requirements must be met in all nuclear power facilities. All facilities must obtain sufficient portable safety equipment, such as devices that could burn off hydrogen if generated in an accident. That graphite with hydrogen, water produce hydrogen that can cause explosion. Facilities should improve their venting to prevent breaking up of steam and control the temperature. Steam temperature, steam reacting with carbon has to be prevented. New equipment must be installed to monitor water levels in each plant's spent fuel pools. So we have to take care of short-term storage in the waste around the nuclear power plant as well. Now, let's look at the pros and cons of nuclear power. Explain your own thoughts on nuclear waste, mining, effect on climate change, cost, and human fear. Anyway, the nuclear waste is minimal. Only thing is there's no tons of carbon released to carbon dioxide into air. So if you can contain the nuclear waste, a lot of problems are solved. And we have to take over human fear. What countries, if any, have long-term plans for dealing with nuclear waste? So we are still negotiating where we can store them. In the cartoon, there are 3 energy sources: solar, hydro, nuclear. There's this guy trying to plug in his lamp, confused which one to use. I think hydro, solar is most safe alternatives, but nuclear power, if we can control nuclear waste, would be not that bad. So now we're going to shift to other alternative source, which is the solar power. You must have seen a lot of solar power panels in the buildings, in traffic highways to generate electricity for controlling devices, cameras, etc. On the rooftop for buildings. Sun's rays hit Earth energy every hour, enough to meet the world's energy demand for an entire year, every hour. But we cannot harness all of it. It gets reflected back and absorbed by different things on the surface of the Earth. However, currently less than 1% only used to generate US power, electric power. So 1% only. So there's a large potential that we can create, at least increase that to 20%. Just compete with nuclear power. So we can cut down a lot of carbon emissions. So we're going to look into some of the issues associated with solar energy. If you look at the diagram, the United States map in the bottom, most of the sun that reaches the United States, what state receives the most sun's energy? Are the southwestern part of the United States, including part of Texas, Mexico, Arizona, and close to the Mexican border, and some into the middle of Central California. So why does more sunlight is reaching these states? This map is from NREL, National Renewable Energy Laboratory. So because they have less cloud cover, desert areas, and high elevation. So they are the ideal state for generating solar power. They could become efficient, produce more electricity from solar power. If should come, and it shouldn't be surprised that California, Arizona, New Mexico, Texas lead these states in average annual solar radiation. They in fact produce more solar radiation. Why do some other these have higher values than other? Like I said, the precipitation is lower. There are less crowd and higher elevation. That's something I can think of. There may be other issues. Silicon as the heart of solar cells, called photovoltaic cell. Photovoltaic cell is voltage created by solar energy. It's based on silicon. Silicon is an element with 4 valence electron. Now they are shared in a silicon crystal by 4 bonds to each other, other 4 silicon atoms. So like in a diamond, so they are happy, all has octet of electrons. Silicon has to be non-conductor, like graphite. No, not graphite, diamond. Silicon has to be non-conductor. But silicon can push out one of the valence electron into another atom, creating a free electron. Hole is created in one of the silicon, and a negative charge is created in another silicon. So this is happening with the exposure to silicon to solar energy, visible light. So therefore, silicon behave like a semiconductor. Silicon is an electrical conductor, but it's not like a metallic conductor. It's a it's partly. So electron can flow through as long as the light shines through into the silicon. But this is very little current for solar cells. To increase the conductivity of electrons, we dope silicon with certain other atoms. There are two ways of doping to fine-tuning electric conductivity, increase electric conductivity. So silicon is doped with element on the next group to the right, arsenic, nitrogen, phosphorus group. They have one more electron. Therefore, they bring into the silicon lattice one more electron. Therefore, they are called N-dope, negatively dope, adding electrons. You can also use less electron, gallium, which is onto the left, to the left of silicon group 4, I think it's group 12, group 13 elements like gallium. So that produce positive holes, less electrons. Therefore, when you add dopant, gallium is called a p-type, p-dope or p-type silicon. When you add arsenic, which has more electrons, it's called n-type. So they are n-type dope with element with more electron than silicon, like phosphorus and arsenic. And there could be p-type dope with elements with less electron than silicon, for example, boron, arsenic, boron and gallium. So that creates more electron flow in the dope silicon than pure silicon. So therefore, we create silicon and dope with these two types. So we use these two types of silicon, N-dope and P-dope, in two layers. The electron flow from P-type to N-type from blue to red. Red is N-type. Blue is P-type. So that completes the circuit. If you run a wire through the outside with a bulb, we can use the electricity flow of electrons to create lightning or electric current. So this is the basic design of PN junction solar cells that is found in solar panels. There are many solar cells soldered together into several solar cells into one panel to create desired 12 volts DC current. When light is hit on the N-type silicon, electrons are freed from the crystal structure and move through the electrical circuit, eventually to return to P-type. There's a barrier. The electrons are not allowed to pass directly from P-type to N-type. There's an insulation layer. So now it can only pass through the wire, outside wire, which is the terminals of the solar cell. When electrons are released by sunlight, holes are also generated in the p-type material. These electrical pairs moves in opposite direction and are the carriers responsible for electrical current. So holes, you can call it electron for flow of holes, positive. Positive current is from positive end to negative end, that's holes. Now, efficiency of solar cells has been increased over the years. There are so many types of solar cells. So right now, it started with 20%, about 20%. Now they have reached to the point where they're about 40%. So you can fine tune the solar cell material, silicon, doping, adding other material to it, increase the electrical conversion, solar energy to electrical energy conversion. The efficiency of solar cells is also increased by creating thin slices of, rather than huge layer of solar cells with thickness, high thickness to short thickness, and very short, about a human hair. So that also increased the efficiency of the solar cell, how thin they become. Only photons with enough energy can knock electron from the doped silicon lattice. As of 2019, silicon-based solar cells have efficiency of 27.6. So multi-layer solar cells increase the efficiency to about 50%, but are very expensive to produce. These design future many layer with thickness in the order of tens of microns could produce more efficient solar cells. So solar cells have advantages. More than 1/3 of Earth population is not connected to electrical network. They don't have a grid. So some people live in remote areas where there's no electrical wires or electricity. Photovoltaic cell is being used to bring electricity to isolated villages in economically disadvantaged countries. They can watch TV and light up their homes at night with a small unit consistent of solar panel and a battery source. So there need to be a battery to save energy during the day and use in the night. So we're going to look into now other alternative energy. We talked about nuclear and solar. So other alternative energies are hydroelectric, geothermal energy, solar panels, waste conversion, wind. So if you look at that, the hydro is on the top with the blue, with most energy. So wind is also picking up, that's a green line. If you look at the way solar is still at the bottom, increasing above all other three. Wind, wood, waste conversion. The solar should be increasing to about 150 or 200 if we put up enough energy resources to produce efficient solar cells. Solar cells could produce significant amount of energy. Among the possible alternative source of energy, wind power has been the largest growth over the last decade. That's the green line. The blue line is hydropower. Hydropower has consistently generated most electricity since 1980. However, average generation of hydroelectric is much less than combustion of fossil fuel. Much less. 3 trillion to 3 billion. So it's trillion times less. Thousands times less than fossil fuel. And there's a problem because the rain is decreasing. There's a problem with Hoover Dam. Water levels going down. Colorado River is decreasing in reservoir capacity. So there are a lot of problems with hydropower now because of the less rain due to drought conditions. So when you think about alternatives, we have to think about that too. The wind capacity in the US, the Texas is a good state, which are coastal areas are good because there's wind coming from oceans in and out of the shore to ocean, ocean to the shore. The wind capacity could be higher. But most of the states are in the middle of the United States, mid south to mid north. So this is because of the average wind speed is higher in the middle of the United States and the coastal areas. That purple and red are in the coastal areas and mid south and mid north states. So Texas have a lot of potential for creating wind, harnessing energy from wind. So Louisiana don't have that much of a wind corridor to produce a lot of electricity. The wind turbine is using wind turbines everywhere when you go on highways close to California and some Texas, certain farms have windmills. So that's a motor driven by a wind turbine. So it creates the electricity and send it to use. The geothermal energy is the energy trapped due to volcanic heat underground producing steam. So top 5 countries use geothermal power capacity are US, Indonesia, Philippines, and Turkey, and New Zealand. So the first state is United States. We do have a lot of geothermal power used in San Francisco area. So this is like releasing hot water from the underground hot water and use them in running turbines and heating homes and other ways to draw the energy. Now let's talk about some of the issues that deal with providing energy in the future. Renewable energy comes from the wind, oceans, geothermal sources, not just from sun and biofuels discussed in chapter 5. Pick one of these renewable energy sources and learn more about the technologies available to harness it. Name geographic restriction, if any, to its use. So some of the wind corridors are restrict the wind power. Prepare a list of the reasons supporting this technology. Please also prepare similar list for the naysayers, those who oppose this development. Predict how the technology will affect the energy production output where you live, especially state of Louisiana. So we don't have that much of a wind power to create energy from electricity from wind power, but we can still convert some energy from solar panels, even though it's not ideal for, like in Arizona, California, southern western United States. Supporters of the nuclear energy encourage its use as source that does not emit greenhouse gases. There is an urgent need to stop subsidizing fossil fuel industry, dramatically reduce wasted energy. Because fossil fuel release a lot of energy while heating steam. Of course, electrical, the nuclear energy also does it, but it doesn't emit carbon dioxide except it produces nuclear waste. Natural gas to wind, solar, geothermal, and other renewable energy sources. After reading this chapter, how do you think nuclear power and renewable energy fit into the world's energy production? Okay, we are done with the chapter 6. So I'm going to stop the class for today. Do you have any questions?